And there we go. Welcome, everybody. I guess we'll start with the agenda. Victor, you have type of scalar subquery expression.
Yeah, this is based on a discussion we were having partially in Slack, and it's come up in a PR. But for context, we had a scalar subquery expression. I'm trying to find this so I can post it in the. Cool. We have this message type, which I can probably link in the. Which is supposed to, at runtime, it's a single column and a single row. But when you're deriving the type of the expression, so the inner relation, in theory, has the type of name struct, which is the inner relation returns some fields, which has potentially more than one. That's a validation issue. But it's like a name struct containing a field, in theory. Is the output type of the scalar expression also the type of the relation, or should it just be the first field?
The way I was looking at it was the way that you are running a subquery which gets you back some number of fields. So if you're, it's especially a scalar subquery, it's supposed to return one item.
Yeah.
And so there's no reason for it to be stuffed in a struct, which is a container, just to return one item. For any other subquery, it would be just the fields that are getting returned. So if there's 10 fields, those 10 fields should be returned. They're not stuffed in a struct. Often things are stuffed in a struct as like as a way of storing the shape as sort of the record type or something like that. Like we do at the top of a root rel. We stuff the shape into a struct in order to store it, a name struct, but still a struct. And so yeah, it should be returning just the individual item, because you're going to then continue to do calculations on it. You don't need to force somebody to unstructify it.
I think that makes sense. And for context, this was coming up because we were modifying the return type of the expression in the Java library for the POJAs. And the question was like, well, there's nothing in the spec that says what the return type of this should be. Is it the expression, or is it just the single inner column, or the entire named expression? I agree with you, David, that it makes sense for the expression to return just like the first field. Cool.
Now the question is, do we need to document that better?
Yeah, I think that's the other thing I was asking about. So actually, I don't.
Okay, so make sure I follow, if that's okay.
Yeah.
So the subquery message that we're looking at is part of an expression tree. So it has one column of data. Right.
If the plan is made correctly, it should only have a single column.
Right. Well, the expression node has one output type. It represents one field, essentially. Okay, but the input is a relation which might emit multiple fields. And so we're saying we'll just grab the first one.
Yeah. Grab the first
well,
one.
That's if it's
Or
something.
throw an error as well, actually.
It should be an error if it has multiple.
Well, what is the output of the? Oh, okay, so this is the case where it's the scalar subquery. Well, really, I guess it would apply. Oh, okay, yeah, okay, I get it now. Sorry.
Yeah, I think before in the Java library, we were just passing back the type of the rel entirely. So it was like the subquery return, or the scalar subquery returned like a name struct of the one field. And we were looking at modifying that. And it was like, well, what should the behavior be? And what should it was ambiguous, I guess. Or yeah, I was underspecified, is what I'll say.
Yeah, that makes sense.
Cool. Cool. That's that item. Any other thoughts on that? Any concerns or questions for anyone else?
All right. Next, you have engine-specific catalogs, which I'm guessing is going to be a bigger topic.
Potentially, this is more a question slash like a fishing line of, we're starting to internally have things of like, okay, we have different systems that want to support different subsets of the standard catalog plus internal stuff. And there's a question about what's the best way to kind of start grouping stuff. And we think that it might make sense to have like engine specific catalogs. And these also make sense in the open source side of things of like, hey, does Postgres support everything in the standard spec? Not necessarily, but can we specify like a meta catalog of like, hey, Postgres supports these things in the standard spec. Data Fusion supports these things, Snowflake, and so on and so forth.
So Substrate Go has some of that. Substrate Go has a dialect. And there's a dialect file that you can specify. And with that dialect, you can say, this function is this when I see concat, use this version of concat that I've locally defined in my own YAML files. And it has this local operator. So in my engine, it's called concat_ws. For some whatever reason, and then or this is an operator that has plus symbol, so it even has some of the mappings from SQL into Substrate, which is useful. And then basically it's a collection of what all the things are that are sort of supported. It says these are my types. It is one way of sort of pointing to the things that you use and the things that you don't use. So there's this general notion of here are all the YAMLs that exist, including the default ones that are in the core and Substrate core, and then there's options to, in your own code, add more YAML files. And then that dialect file basically picks and chooses the ones that you define as being part of your usable function set. And then once you have the dialect, you can say, okay, I have this signature. Which YAML file is which entry in the YAML files actually applies to this, so that you can go and do the lookup.
Okay, yeah, so it sounds like if the Go side is looking at what's in terms of dialects, I guess the thing that I want to be able to do is I want to pull that out of Go specifically and into like Substrate, the core specs somehow. Because like one of the things that we were thinking about long term is like if we had a catalog, actually this came up as part of the discussion we had in the CalSite meetup, where if we had, for example, a meta catalog of like these functions are allowed by Postgres, you could theoretically, for example, feed that into CalSite to be like, hey, are you trying to run this file in CalSite? Load the catalog in. This catalog tells you all of the functions that will have to push down to CalSite or to Postgres. Use that for plotting purposes. But for that, we need it in like Java, or if it was in Substrate, the core spec is in some weird meta YAML file, we could do that. But it sounds like, okay, it sounds like there's prior art for this, and this is definitely something that would be of use or interest. Like if you were to try and do something around this or propose something around this, or would it be like this doesn't belong here?
Right. We basically would need to pull that out of Substrate Go and up in the core. If we want to continue with that particular approach, or if we want to try to define a slightly better approach. A naive approach would be to just take all the YAML files and stuff them into one place by system, and then do duplication. And yeah, I'm not sure. I think the dialect file is probably a little bit better, because you can then you would even be able to see which things are shared between different systems, based on the definitions and things.
A cursed version of this that we thought about at some point was having a configuration script that would basically generate function-specific variant catalogs from the core, being like, hey, functions arithmetic for Postgres supports these functions, and all these other things run this thing and generate a subcatalog of like, this is functions extent, this is functions arithmetic for Postgres, functions arithmetic for string. But
right. So for the stuff that that we've been doing at Sundeck, there are some decimal, like a lot of things are a number, which meant everything was decimal based instead. So for string operations, instead of we ended up creating analogs, which were decimal analogs of things that took in integers or returned integers, like stir pause and things like that. So we ended up basically creating alternative versions of those functions, and those were and exactly that. And then being able to pick and choose which ones you want.
Yeah, I mean, there's function. I would avoid trying to specify function options just because that gets complicated. So like you might list the add function. That doesn't mean that Postgres supports all of the options in the add function. It just means there is a function named add that you can call.
Yeah, for the way we used it, we actually ended up specifying options in the cases where we had options, but yes, it does get confusing. And in general, not many systems actually are doing well at supporting options right now.
Yeah, but they all hard code to one or the other.
Yes.
Yeah, that answers, I guess that answers like the meta question answers. I don't have a specific approach for this in mind as much as it sounds like, yeah, Sundeck, you're doing something similar. We're sort of thinking about doing something similar. There's probably utility in just having a general one of these that we can be like, hey, this is Postgres, this is Snowflake, this is all these open source systems. And then for us, we can be like, cool, once we have that, we can use that for our internal BS.
Yeah, at one point, my hope for the BFT function testing stuff was that this would be an output. So like you take all your test cases, you throw an engine at it, and then all the test cases that pass, I don't know if it's an input or an output, but it'd be an artifact. Like all the test cases that pass are your list of supported functions for that engine.
That makes sense. I guess for other folks who I think I haven't seen the meaning for BFT is the big function taxonomy.
Yes.
That's still what it's called.
And the test cases, like,
go ahead.
Yeah, the test cases stuff that got moved into Substrate late last year is based on the BFT work, and that we heavily rely on that at Sundeck in order to determine what things can be done.
Are folks still working on BFT stuff? I think that was primarily Voltron. I know Richard was doing a bunch of that, and I know that that's no longer seems to be a priority.
BFT is not getting as much, but the test cases stuff has been. Been getting a lot of work, at least, especially in Substrate Go.
Cool.
All right, those are the two agenda items. I'm sure there are non-agenda related items that we'd like to talk about.
Hello, I'm new to this meeting and just wanted to say hi. Srinivas and Todd are with me working on the same project. We are working on Bodo, which is a new compute engine using HPC backend, MPI, JIT compilers, and things like that for Python and SQL. And we are looking to build a data frame library interface and trying to figure out how to build our optimizer and connecting to the backend. So Substrate seems like an ideal solution. But the challenge is, we have an optimizer based on Calcite for our SQL side, But for Python world, ideally, you should avoid Java altogether. We have Iceberg support, and we're getting rid of the Java side over there. So wanted to know your thoughts on the optimizers that support Substrate today, and other than Calcite, anything that's not Java, and what is the status of those? If you guys have any thoughts, I saw Data Fusion effort with Substrate. If you have any thoughts on that.
Yeah, I would say the two big optimizers that aren't Calcite that are open to a degree are Data Fusion's optimizer and DuckDB's optimizer. Both of those components translate Substrate to logical plans, but they do not translate Substrate to physical plans. So the Data Fusion does have like a logical optimizer and a physical optimizer. So you would be able to convert from Substrate to Data Fusion, run the logical optimizer, and then convert back the optimized logical plan to Substrate. But if you went all the way down to like the optimized physical plan, you wouldn't be able to convert that to Substrate today. So that's the biggest challenge. And the reasoning there is like an optimized physical plan tends to be very specific to a single engine. And so like Calcite works around this by having, I forget what they call it, but like a lot of interfaces for your engine to kind of tell it, here's all of the physical things that I can do. And there's no real equivalent to that anywhere else that I know of.
Mm-hmm. But the optimized logical plan, actually predicate pushdown, column pruning, join ordering, all of those things are done, but not, this is the type of join you should be using.
Something I'll distinguish as well is that Substrate doesn't really care about optimization per se. Like there are integrations that let you pull Substrate into like Calcite and Substrate into Data Fusion, but you still have to configure the optimizer yourself, if that makes sense. Like Isthmus, the library for Calcite, like knows how to transform from Substrate to Calcite and back from Calcite to Substrate. And we use it internally at Datadog. And what we do though is we go from Substrate to Calcite. We have our own optimizer of our own rules and a bunch of the standard ones, and do the column push down and the column putting on all that. And then we convert back to Substrate using the library, but the library itself doesn't have opinions about optimization. Like the optimization is up to the user, and that's part of what Weston was saying, that like we want to make it easy for you to go into the optimizer, but we can't necessarily say like, what is an optimization for your specific system that's useful?
Yeah, definitely. I understand that. Just trying to figure out what the optimizer options are. Basically, DuckDB, Data Fusion, and on the Java side, Calcite. Any thoughts on DuckDB and Data Fusion, how good the optimizer are and how extensible they are if someone wanted to customize them?
DuckDB's is going to be, I would say, lots. Well, both of them have extension frameworks for adding new rules and that sort of thing. I don't think either of them have, to my knowledge, like a popular implementers of those extensions.
Mm-hmm. The Calcite is really extensible, and we built on top of it a ton of things. I don't think there's any equivalent out there. And one last question for Substrate. Obviously, a lot of things are SQL based, but I hope there's intention of being open to Python and the things that come. We are translating pandas. So, has anyone tried anything like that? Translate pandas to Substrate?
There was a bit of discussion on it a while ago in the Polars channel, because they were looking for some kind of serialization option. I think they just abandoned the project entirely. Not Polars, but serializing the plans. So there's like a different opinion. I think one of the things that came up is a lot of data frame operations. They are relational, but they're multiple. They're the execution of multiple plans. So like a data frame one-liner might be that you calculate the min of this filtered thing and then use that to set this other column over here. And I forget what exactly it was, but it was something like I can write this in one line in a data frame, but it would require 2 substrate plans that I would execute one and then take the output from that and execute the other, or something like that today. I'll dig up that conversation.
That reminds me a lot of the way Spark works with its data frame. It's like, oh, I got one plan, and then oh, I got another plan. Yeah, when it's doing its data frame stuff.
Yeah, let me.
Yeah, I think that makes sense, because you get a scalar out. You're in Python. You have to kind of get the output. You can't delay that unless if you go do something crazy, which or what the end-to-end JIT compiler we have. But that's a different story.
Yeah, I did do I did convert Spark data frames into Substrate. That was a fun little project in Python. So that's something fun to play with. I actually had some transformations and things which I did in Substrate space, converting, like replacing virtual tables with named tables or whatever was necessary to get it to run on whatever backend.
Like I think that a lot of the Substrate spec is definitely tied to SQL, or what we will represent all of SQL, but I don't necessarily think of it as I think having other things that map into Substrate is fun, as long as they're vaguely relational model-ish. It tends to work.
Absolutely. And in terms of getting started for us, our system, we are a ton of different languages, but Python front end, a bunch of C++. What do you guys recommend to get and trying to avoid any Java, Kotlin, all those things that we have in other places? What do you guys recommend? Is the Python implementation a good starting point, or do we have to, do something else?
Python implementation of Substrate?
Yes.
I guess maybe to answer the question differently is that the core Substrate itself is just the protobufs, and then the various languages. We have libraries that have varying degrees of support. One of the best ones right now is Java, unfortunately, because we use it at work for Calcite, so we spend a lot of time on it. I know David does a lot of work on Substrate Go for Sundeck, so there's integration. So I think the Python library right now, I'm not sure what the state of it is. At the bare minimum, it's probably protobufs, but I don't know if it has any utilities beyond that for working with plans and making it easy. I've never looked at it.
It doesn't have a builder, which originally we thought we didn't. It was thought, oh, this is simple enough. You don't need a builder, and you don't really need a builder. But having a builder makes it a whole lot easier to write expressions. For instance, being able to just say, I just have this expression, or I need this literal. You can write the protobuf, and it'll be 10 lines of whatever to make the protobuf. But having something that you can write it in a single line or half a line is certainly a whole lot better. So I would love to see in the Python to have a builder, sort of like what I ended up doing, but probably a little bit more disciplined. In the Spark Substrate gateway had a Python builder esque, or at least a V1 version of it. So that's what I'd like to see in Python. That would be the thing that would make the library usable for me. C++ is probably also pretty thin. There's not much in the way of a builder, but it has a nice visitor. So you can actually visit a Substrate plan. I think that's probably another thing I would think is a minimum. That you need a builder in order to make it easy to make expressions, because you're going to always need them if it's only for tests or something. And it's nice to have a visitor so that you can go through and you can pull out the information you need from a Substrate plan. So I would say those are the two minimum things.
So I'd agree. I was at one point I kind of embarked on, I'm going to make the Substrate library for Rust that has all those builders and things like that. And then I've sort of abandoned that, and what I've decided is that I'm just going to think of data fusion as the unofficial Substrate Rust implementation, because I can just use their logical plan builder, and I can build a logical plan, and then I can convert it to Substrate. So like now I have a builder. So in some ways you can get around like that. That works. I mean, it's not code-wise for usage. It's not going to be any different than if I were to have an actual Substrate Rust builder. It's just a bit heavier of a dependency than I would like. So in some ways, Rust has good support for working with Substrate if you're using data fusion, because you can use that as a plan builder and logical optimizer and that kind of stuff. And then you can bail out to Substrate when you need to send it to a different component. So I was wondering with the DuckDB Substrate extension, I don't know if there's anything similar. Like, I don't think DuckDB has C++ APIs for building plans. I think they prefer kind of all their input to come in as SQL.
Pretty much. And then you don't have, some of the optimizations happen automatically. So if you had a subquery where I forget exactly what it is, you're forced into having a delimiter join, and they have it. The code there doesn't yet. The extension doesn't support delimiter joins. We have the new expression, the new stuff that we added for their support, which was the I guess the the cache hint for sharing cache information between parts of the plan that needs to be implemented. Maybe I'll do something like that. So I'd like to see that work. So yeah, there's some things where DuckDB you can't do stuff. So it doesn't support. I think 6 of the 22 TPC8 queries don't work on DuckDB because of subqueries. They would certainly work well by themselves, and they're really, really fast if you're stuck with SQL, but the SQL won't go into Substrate, and so you can't specify those kinds of plans.
That makes sense. Thank you guys for all the information. We have a lot to think about.
And you're on mute, Victor.
No, we're always happy to hear about new people trying to use stuff, and it's very much a work in progress. It turns out there's a lot of SQL/relational systems/algebra to represent everywhere, and slowly chipping away at it.
Yeah, absolutely. And in the Python world, the situation is not great in terms of relational optimization. So I think there's a lot of opportunities there.
Yes, I put a link to the Polars issue in the chat. There's a few examples there. I put one there as well, which is like adding a column to the column reversed. So that's something that's very data framey, but you would not really see in relational algebra. You could turn it into kind of 2 plans, where one, you do a sort, and then you take the output from that sort and you feed it into your second plan. But it's where things get a little bit interesting when you look at the two of them. So like data frames will typically make the assumption that everything fits in memory and that I can easily reverse things and stuff like that. And so mapping that to relational plan can be interesting.
Yeah, as this assumes order. That's very strange. I don't think Pandas has a reverse function like this. I don't know why they decided to do something like this.
Yeah, each Pandas has things that assume order, but I don't know if they have a reverse function, like cumulative sum. But that can be done like with a window function. Sometimes things that assume order can be done that way.
If I can ask, I know, was it about a year ago when we were looking at Substrate for another reason? We were trying to look for a more human readable format to constructing. And I know there was some discussion about it. I think it was linked to the C++ implementation.
That would be, yeah, that'd be the text format. It didn't make it, it hasn't made it into Python. There's a PR out there that would try to get it in, but the dependencies make it difficult to get into Python. It's because it's C++, it's wrapped C++ code.
Oh, okay.
But then you've got all of the you've got the Antler libraries. You get the aren't really the big problem. The problems are like the protobuf libraries, because now you have a duplicate set of protobuf libraries in it's stuffed in your Python module. I'm thinking that probably to make this actually work, I was thinking last week that what I really need to do is create a separate module just for the text format.
Just
But the other ways that people have also talked about is like, oh, you should just write it in Rust and then and then and that would be easier to pull into other languages.
I guess the question sort of us is for reading the plan is reading the plans. Is it primarily like reading the substrate plans that would be produced, or is it from what I'm thinking about, or also writing them in a more compact format?
Mainly for reading purposes, especially for working with plans and being able to just modify them around and test the runtime implementation, the physical operators against different variations, especially earlier on when we were working on our planner for things like getting the drone ordering right when we didn't have all of the heuristics set up. It would have been easier for us to just do it manually and have the team that's working on the runtime test it that way.
Yeah, having the ability to display the stuff in the text format, it really made it much easier to read. These days I am much better at reading substrate plans in JSON, but I still think I prefer the text format.
That's not ideal, and I'm very good at that as well, and it's still not ideal, and it's also hard to encode stuff for tests. We have a lot of golden tests. Not anytime soon, but we do have some internal stuff that we're thinking about open sourcing, which is in a format that you could write, or it's a read-only kind of thing. It's based on what CalSite kind of outputs. I can't promise this will be out anytime soon, but we've talked about open sourcing it, and whenever I hear people being like, "This is a problem," I'm like, "Cool, I'll add a note to my file of like people who are interested in something like this."
All right, on to other potential items to talk about. I think there is only one PR out there that could use some help. That would be adding some decimal arguments to round, I think. I've approved it. It needs a second's approval. The big complicated part in this thing is determining what the actual decimal values should be for round, or the precision and scale. Coming up with a computation for those is especially if you know what the values are, you know what the right answer is. But a lot of these times you don't know what the right answer is, and you're sort of stuck returning the max precision and scale, or something that is potentially, except that it's not really max precision and scale, because when you're rounding, you're obviously dropping some of the precision as a result. So anyway, it's worth taking a look at, seeing if we can push that one across the finish line. It's been out there for a while. And you're not going to just look at it in the next 30 seconds and come up with an answer.
Every time I look at decimal stuff, my brain hurts.
Yes, exactly. You're not going to look at that in the next 30 seconds and come up with an answer whether you're satisfied or not.
At some point in the near future, I need to make a PR to Isthmus to showcase an issue where there's a problem with round trip conversions of decimals, which doesn't show up because when we run the round trip test, we start with the calcite schema and when we come back, we use the same calcite schema. But actually, if you generate the schema from the returning substrate plane, they no longer match up. They're not quite round tripping, and I'm not sure why, aside from decimal curses. It's on my list of things to do to make a PR to showcase that something's happening.
Sounds fun.
Oh.
Well, that's the end of the items that I know that we might want to talk about.
Same for me. And I guess, yeah, for all the new folks who have never met, hello, welcome. And yeah, if you have more questions, you can ask them in the, I guess we have the Slack is the most active place to, if you want responses. We technically have a mailing list that I think people will look at periodically, but we're better at mailing lists, I guess.
Hey, we've got one message every 2 weeks.
This meeting.
Yeah, thank you guys very much. It was very helpful. We'll definitely bug you guys on Slack. I'm already on the Slack channel.
Yeah, perfect.
Yep, great. Thanks, everybody. See you
Thank
next time.
Bye.
Thanks. Nice meeting everyone.
Yeah.